There were few setbacks during the rocket build. Almost everything went according to plan as far as the acquisition of materials and the build itself. The materials needed included 8 2-liter plastic soda bottles, 4 plastic caps, 6 triangular fishing weights, and 2 rolls of tape and a foam poster board. Using the tape, we attached the 2 soda bottles together at their bases. We then cut the poster board into 16 triangular slices that we later taped to the sides of the rockets, with 4 fins on each rocket. We positioned the fins according to the dimensions that were drawn out by the fin placement board in the back of the room. Later, we drilled a hole in the center of each bottle cap and attempted to attach the fishing weights to the caps by cementing them together. We tried this using a form of rubber cement, but failed. The rubber cement never actually hardened, allowing the 6-ounce fishing weights to fly off during the rocket's flights. Once all of the parts were attached, we found the weight, TCG and ACG, theoretical center of gravity and actual center of gravity. When it came time for the 45-degree launch, we had already lost 3 of our 4 weights. Due to this, we ended up deciding to go with a different method of attachment for the remaining nose cone. Using a small bolt and nut, we screwed the weight to the cap. In retrospect, we should have done this to begin with because it likely would have prevented the other 3 weights from falling off. While completing this initial aspect of the lab, we learned the importance of precision and planning ahead. By placing our fins on properly and making sure all 4 rockets were of the same weight, we were diligent in our building. Unfortunately, our nose cones were not identically shaped and only 2 of the 4 had identical masses. This caused problems later on during the 45 and 90-degree launches. We learned to take note of the building materials before it became too late to fix. We also discovered a perfect way to attach the nose cones to the rockets, but that didn't come until after we had lost 3 nose cones. Next time, we know to try all methods before settling for a less effective one. By planning ahead and demanding precision, we could have had perfect results. We will use this knowledge in the future when building everything from more rockets to do-it-yourself repairs to engineering devices in potential future careers. The lab taught us the importance of proper engineering, attaching vital components with care, not with insufficient cheap materials. We also learned the importance of teamwork and that splitting up a task between a few equally participating members is much easier than an unbalanced workload. Since we managed to do so, our group got along well and everyone was eager to participate. Most of the group members enjoyed building the rockets because it was easy to replicate them and it was the most hands-on aspect of the lab. There was always something for everyone to do. However, it was frustrating to get all of the rockets to have the same masses and to have the fins be angled properly. Constructing the rockets was very unlike any other project we have completed because we needed to consider functionality, practicality, and identical setup and aesthetics.